Now it's time to learn about exception handling in Solidity. I want to get started with require and then head over to assert and then show you a few things with revert, named exceptions or custom exceptions, and try catch. If you come from a Java background, you are probably going to be a little bit disappointed. Exceptions in Solidity don't work quite the way you're used to them, even if you don't come from Java like Node.js or even PHP. It's not the same. Let me show you what I mean. Let's get started with a simple example with a simple smart contract. I'll just call this example exception requires Solidity, and over here we are going to bring over, yeah, you guessed it right, our XPDX and license identifier in the pragma line. And this time, okay, let's call this contract example exception require. And what I'm going to do now is I create a deposit function, and I create a withdrawal function with a simple mapping. And for the withdrawal, I'm going to check if the amount we are going to withdraw must be smaller or equal than the balance we actually have. And instead of using Solidity 8.15, I'm going to use some smaller version like 7.0. And the reason for that is I want to do that with the integer rollover example. So it actually makes sense to have this require statement. Anyway, you should always check if the withdrawal amount is smaller than the actual amount available, and so on and so forth. So input validation is a thing that you should always do, no matter what kind of Solidity version you have. But that's a different story. So let's create this mapping, address, unsigned integer, public balance received. Then we have a function receive money, public payable, and that is going to increase the balance for the message sender. And then we are going to have a function with a draw money, and over here we have an address payable to and an unsigned integer amount. And we are going to check if the amount is smaller or equal than the balance received. Then we are going to decrease the balance received by the amount, and then we are going to transfer the amount to whoever is the lucky address to. What did I make here? Oh, of course, message value. Okay, so now it compiles. If we are going to deploy this, and I'm going to send, I don't know, 100 way to this smart contract, receive money. So how much do we have in there? We have 100 way in there, and I want to withdraw it back to me. And I'm going to withdraw 1,000. If we hit transact, well, we still have the balance here because nothing happened, because the amount that we tried to send is larger than the balance received balance that we have. But the transaction went through, and that's just not a good thing. You want the perfect, or you want a good user feedback from your smart contracts. You want to tell the users if something went wrong, and this is where require comes in. Require is for input validation, and it can also output or send it throws an exception, it rolls back the transaction, the complete transaction, and it gives you optionally an error message. So instead of the if, we can write a require here, remove the curly brackets, because that's not a control structure. And we can have an optional error message, so not supporting. Yep. So what happens here is that this part of the require, if that evaluates to false, then it will roll back the complete transaction. So no matter if this is the last statement over here or the first one, everything that happened within the transaction will be rolled back. It is as if this transaction never happened. And this error message will be outputted. What internally happens is it is actually, when it's compiled, it is changing the require to revert error, and then whatever is the error message. But I'm going to show you this in one of the next lectures again when we talk about custom errors. Okay, let's run this. Let's see what happens. I'm just going to deploy the same smart contract over here again. So we have 2 instances. We are going to send again 100 way to our smart contract. And then we are going to try and see if we can withdraw more than the 100 way back. So I'm just going to withdraw 101. So what happens here is now the transaction is actually not successful. Status is false in this case. That's important to understand. And we are getting a revert back. And the error message, the reason provided, is not enough funds aborting. So you can give the user feedback when something happens that shouldn't happen. And require is for input validation. So it will use up gas until it hits the require statement, and then it will return the rest of the gas. So even if you say you give the smart contract 8 million gas, if until here it only uses 50,000, then it will give back 7,950,000 gas to the user. It's important to understand that because in the next lecture, we are going to talk about assert, and assert is for a different purpose. So stay tuned.